Hey there YouTube, welcome back to the Death's Doorstep Devlog Part 2. Last time I focused on how I create levels in Unity 3D using sprite shapes and tile maps. This time around I'm going to focus more on state machines and the state machine that I created in order to build my game. There are options for state machines in the Unity Asset Store. If you don't currently use a state machine and you're making a game, I would highly recommend either checking out those ones or maybe looking into running your own. Probably look into the existing ones. Honestly, there isn't much of a benefit of writing your own as much as I enjoyed writing my own. But it will definitely keep your code a lot cleaner in the long run, especially as your game gets more complex over time. I definitely noticed improvement in my coding structure as I built this game and moved over to more of a state machine than I did at the beginning when I was just kind of like tossing a lot of code into a class. So instead of going in depth as to how I built it in the code, I'm going to focus more on a high level approach as to how it works, as opposed to focusing on the mummy object, which has a lot more states. There's a lot more work to explain. I'm going to keep it simple and start you off with the jellyfish, which really only has 4 states. So to walk you through what those states are, it has this idling state, which I call floating. As you get closer, the floating state will get angry and a little bit more agitated. A little bit more like the fish in Super Mario World. When you get too close to them, they chase you. And then if you get too close, he chases you, which is called the creeping state. And you can see he's got his angry eyes going, and he follows you around. And then on top of that, he also has a hurt state, which is those X eyes, and the dead state, which you saw very briefly, basically just offs himself and then cleans himself up. So I'll show you how that all works at a high level. So if I go remove maximize on play, as you can see, the jellyfish here has one component which is called root. This basically controls the state machine itself. Body and friction are more related to the physics, so we're not going to go in depth there. So root, as you can see, is basically empty. It has a debug toggle and you don't see any other states here. So if I click on this debug toggle here, you can see all the different states that it's switching between. So as you can see, it enters a floating state here, and then if I get too close, it'll enter a creeping state, and it'll chase me around. If I hit it, it'll go into a hurt state, and then back into a creeping state, and then I'll jump on it, it'll go into a hurt, and then a dead state, and then it's gone. As you can see here, there's a component called floating that wasn't there before. So, and when I get closer, that component will disappear, and creeping will show up. And then floating. So yeah, you can see that the current state is basically just a mono behavior that is being toggled on and off the object. So the root object is actually pretty simple. It's just a state machine. I'll show you the code real quick. So here's the code, and you can see that there is a protected override void states, which is where I define the states for the object. You get the initial state, which is floating, as well as defining optional states that may be hit during the life cycle of the object: creeping, hurt, and dead. So these are classes that are mono behavior classes, and the root object, as you can see, is inheriting from stitch.root. Stitch.root deals with adding these components to the object at runtime. I don't really want them to show up in the editor since I can't actually edit things on the state. States are pretty simplistic. They don't have public parameters or anything like that. They're self-sustained. They get toggled on and off, and they deal with their own logic themselves. So let's take a look at the floating states. So the floating state, you can see there's an enabled and a disabled function. If you're familiar with Unity, on enable, on disable are very similar to these wrappers. There's a little bit more logic that I've added in there just so they get called when I want them to. But basically, when entering this floating state, enabled will be called, and this chunk will be called. When exiting the state, this chunk will be called. You can see here there is a draw and a physics. This correlates to the Unity update lifecycle method, as well as the Unity fixed update lifecycle method. So here, draw just updates the rotation based on the speed of the object. It's simple, it's just a little bit of polish on top. Physics, on the other hand, is what actually controls how this object moves out of the floating state and into the creeping state. So if the vector2 distance of the mummy to its local xy is less than the attack distance, whoops, then switch into the creeping state. If it's close enough to, the creep distance. Okay, well, whatever. If it's less than the creep distance, give it the grumpy eyes, or else just give it the sleepy eyes, which is how it starts out. So that's what switches between the eyes as well as the animation speed of the object, as well as how we switch into the creeping state. At which point we can check out the creeping state, which has similar enabled, disabled, draw logic. And then in the physics logic has the opposite, where if you're too far to creep on the mummy, then go back into the floating state. Otherwise, if you're within distance, then accelerate to the mummy, which is the behavior you see when that jellyfish is floating around. So if you get too close, he gets angry. You get even closer, he chases you. If you get too far, he'll give up. So that's the basic functionality of how this jellyfish works. And then on top of that, there's also the hurt state. So the hurt state isn't actually getting done by, like, in the actual jellyfish life cycle. The hurt state is managed by the whip collisions, the mummy whip collisions. So here we can see the jellyfish enter. So this is just forcing the object to move based on the attack that was done. So you can ignore that. But here you can see this is where collision.other in this case is jellyfish. This is hurting it by 1 damage and then telling it to enter a hurt state. And then once it's in the hurt state, it handles all of the logic itself. So the mummy puts the jellyfish into the hurt state and the jellyfish handles the cleanup of itself. So in this case, it checks its HP. If the HP is too low, it immediately goes to the dead state. Otherwise, it puts on the hurt X eyes, as well as changes its animation speed, and then kind of does a little wobble animation, as you can see here. This is just doing some easing to show the impact, and then waits a little break before entering back into the creeping state, where it starts attacking the main character again, the mummy again. So hopefully that was straightforward enough. I've only really shown you the jellyfish to this point. I can show you the mummy real quick, although it is a lot more complicated than the jellyfish. So instead of diving into how the code actually works, I'm just going to show you the list of states that I have, really. So let's turn on the debug flag for the mummy. Make sure we turn off the debug flag for the jellyfish, or else it's going to be hard to see all the logs. And then let's play. So you can see here, the room starts with the drone state being initiated for the mummy. Drone is basically allows another object to take control of the mummy and then exit back into a separate state after the fact. Let's make this a little bit bigger. Here we go. And then immediately it went into the standing state after the fact. So if I start moving, I'm still in the standing state. I actually kind of want to break that into separate states for walking and standing. I'd rather share the logic using a custom service instead of just having all that logic live in the same state. Same with running. Running is also the standing state. You can see I'm not actually changing. As soon as I jump, there's a jumping state, back to standing, a gliding state, back to jumping, and then standing. And then here's where it gets fun. So I decided to make the whipping animations each their own specific state. This is quickly becoming useful for allowing me to have input buffering on the different states. So if I mash the button a little bit faster than I can for the attack, it'll take and do this 2-hit combo. As well as if I do it a little bit too late, it'll immediately do the initial combo again. It just really helps me add polish to the object itself, or to the state itself. So you can see, hopefully you can see at the bottom there, that when I do whip 1 and then whip 2, those are separate states, and then it returns back to the standing state. When I do a jump, it does a whip air, and then jump back to the jumping state, back to the standing state. Whip 1 again. Whip 1, if I do it a little bit too late, it'll go back into the beginning of whip 1 again. So there's like a no delay between the whip 1, as you can see there. And then the whip run and whip up. So it's really just a convenient way to write your classes. It keeps everything cleaner in the long run, which allows you to spend more time on focusing and debugging, as opposed to just jamming everything in one class. So again, if you don't use state machines, definitely check it out. It'll help you a lot, and honestly, I don't think I have anything else. If you have any questions or want me to jump into more detail on some of the things I showed off, feel free to shoot me a message in the comments. Till next time, see you later.